Okay, so today we are going to talk about Kafka streams and low compaction, and it's very important thing. So a few days back when I came back from my holidays, uh, so someone new in my team had to work on the Kafka streams. So and he have to create some topics. So he had done the marvelous job of completing that Kafka streams related work, but when I tried it, and in just 3 hours my storage, I got out of storage. I have like 200 GB partition, and this is what it happened actually. If I can show you, after in during the processing I got no space left on the device. Okay, and I have like 204 GB of, and I was just left with 2.1. And in one of the partition, okay, in the partition, one of the partition had like 7.6 GB of the data. And so as I have realized that there is something wrong with the log compaction, and that's why I got out of storage. So what I've done, okay, so after enabling the log compaction, okay, before it was when I put on the volumes, it had like 102 GB of the space, and it's without log compaction enables for 9 topics. And when I have enabled the log compaction for those topics, and it resulted in 3.4 GB in total. Okay, if I can show you, we have 3.25 GB. So imagine a partition had 7.5 GB of data, and now the total space utilized by 9 my topics and the Kafka stream topics, intermediary topics, and change log topics, it had 3.45. And without log compaction, the only partition, the single partition had 7.5 GB of the data, same data. There is no difference in that. If I can show you real quick the Prometheus, okay, we have like 100 events. Okay, it was related to streaming related. Okay, so what and in order to take into effect, if I can show you just that Docker prawn, volume prawn, it has just 3.83. okay, it was after using the log compaction. So before we do anything with the Kafka and Kafka topics, we should be well aware of these kind of gotchas. Okay, we should know what we are doing and what impacts it will be having on the system. Okay, otherwise it is going to become it will lead you to a place where you really don't want to go. And at the end you might blaming the Kafka. Perhaps you should have learned well before doing anything with Kafka. Okay, so long story short, whenever we need to implement something, we definitely need to read before doing it, because Kafka is distributed system and it handles things differently. So we should be looking into the nitty-gritty details. And as far in this case, just I had to enable the log compaction and the segment retention, millisecond retention, that it should store for like 1 minute or 2 minute, or depends upon the time frame you have, and it actually depends on the use cases as well. So if I can show you quickly, now it's working and producing some data. And if I can simply produce another record, just I will be enabling. Let me just go to the Prometheus and set it to last 1 minute. Okay, we have just one record. Okay, and once I update the version, it should be reflected. Okay, so as you can see, Debezium has done a marvelous job on producing these metrics, and I'm really uh, thankful to the Debezium team for doing this sort of for for making our life very easier. Okay, and if we go to the Kafka streams, as you can see, it has been processed successfully. Okay, and that other thing was, after implementation, okay, so we needed log compaction comes into effect if we have unique keys. Okay, so the key matters a lot in log compaction. If we don't have this key, okay, then the log compaction will not work, because there is no way for Kafka to know that which records to be deleted. Okay, if for instance I have 3 records in a topic, and they have their keys, then and I will push record with the new key, I mean record with the ID 4, then it should if we have a record in Kafka topic with ID 4, then it should be deleted and actually replace the newly created record should replace that specific record, and in this way we get a storage. Okay, so that's why we need to have this select key in the Kafka stream to produce to these topics with a key. If we don't do it, it will not work. Okay, so we need to be careful with this approach. Okay, and for other part, okay, so and the other thing was very important for the configurations topic. Let's quickly look at the command. Okay, let's clear this out. Okay, so this is the command which I am using to create multiple topics, okay, with the replication of factor 1 and partition 4, and this is the configuration to store. We have some messages with which needs more memory than defined one, so and the cleanup policy needs to be set to compact, and this is important one, and this is the time which Kafka does the cleaning part, I mean cleanup part. It will delete the duplicate messages after every 300 milliseconds. So this is the important configuration, and it was just missing. Okay, I have to add these two configurations to enable compactness for the topics, and it will automatically be reflected on the topics which were created by Kafka stream application. If I can quickly show you. Okay, if we go to Kafka topics, bootstrap server and broker. Actually, at the moment my Kafka broker is running in Docker. So let's list the different topics. These are the topics, okay, which we are creating, which have these are the actually tables. In few of them have the topics with tables in our database, and few are the Elasticsearch sync related topics, where we push the resultant records so that it can be ingested into pushed to Elasticsearch. And these are the topics which are created by Kafka streams. So these topics have a lot of data, and these are the change log topics, which ultimately keeps tracks those topics, like this one. In case of failure, the Kafka uh, pulls the data from these topics, okay. So if we just describe it, okay, Kafka topic bootstrap server broker 92, and describe, okay. Sorry, I made a typo. Okay, so it has cleanup policy as compact, and message max byte, and timestamp, and create and it has segment ms 100. So it cleans up Kafka streams related topics are uh, using their built-in as cleanup policy, like they have defined 100 milliseconds. So that's otherwise this topic will be filled with a lot of data which could have been related. So that's why the Kafka stream itself imposes a policy to clean up these data after every 100 milliseconds, okay. And if we go look for describe this topic, okay, so we have defined for 300 milliseconds. So that's why it is now using less memory than it was using before. So these were the some important configuration which I wanted to discuss. And if we go look at the Kafka partition code, we have different joins, okay. The aggregation takes a lot of data, okay. That topic, if I can show you in the tweet which I done, here you go. This is the topic: tests SMS public convocation information all aggregated. It had 7.6 BF data. So if we look now for it, okay, and it has this cleanup policy with every 300 millisecond. And if we look into the var lib Kafka data and search, we have it. And if we look for how much memory it has been using, now it is 13.13 GB, and it will ultimately gets deleted when log compaction will take into effect, okay. So I thought I should produce this video because I thought it's very important concept which need to be learned and shared with. So thanks for watching.